Solving Systems of Linear Equations Graphically, Lesson 9 Notes, the review. The review is a separate assignment called Solving Systems of Equations Graphically Notes Review. Find it in Schoology, upload it to Notability, complete it there, and then resubmit it. It's the 4 questions you see here. If you need help with finding the least common denominator for 1 and 2, I would refer back to the notes for multi-step equations. All right. This lesson is on solving systems of equations graphically. We're actually going to learn how to solve systems of equations using 3 different methods. We're going to use graphing, which is this lesson. We're going to use substitution, which is the next lesson. And then we're going to use elimination, which is the 3rd lesson on solving systems of equations. Before we get started with the notes, make sure you have the definition for systems of linear equations, parallel lines, and coincident lines. So take a moment and get those definitions written down. All right. Let's start with the definition for systems of linear equations. So, a system of linear equations is a set of 2 or more linear equations that have the same variables. For this lesson, graphing, the variables are always going to be x and y because we're going to be graphing on the coordinate plane, so we're going to use x and y. Once we get to substitution possibly, but definitely elimination, the variables could change. Instead of using x and y, you might use r and s or something like that. This is what 2 equations that would look like for systems of equations. So go ahead and write down the example x plus y equals 12 and 3x plus 5y equals 50. All right, I know you don't know how to do this yet, but I'm going to tell you that the solution to these 2 equations, in other words, I need to find the values of x and y that are not only true for the one equation, but also true for the other equation. So it has to work for both equations. For this particular problem, the solution is a one-solution problem, and it is x is 5 and y is 7. If you would plug 5 in for x and y in for 7 into each equation, the equation will remain true. 5 plus 7 is 12, and then for the other one, 3 times 5 is 15, 5 times 7 is 35, 15 plus 35 is 50. So the ordered pair 5, 7, or in other words, x is 5 and y is 7, is the solution to this system of equations right here. Again, 5, 7 is the solution. Now, when you solve systems of linear equations, and if we're going to do it graphically, then what you want to do is you graph each equation and you see if the graphs intersect. So we're going to be given 2 equations, you're going to graph them, and you're going to see if they intersect. If they do intersect, then the point of intersection represents the solution, or the solutions of the systems of equations. So where they intersect is the solution if they are intersecting lines. So once again, above parallel lines, I'd like you to write this down. Intersecting lines are one solution. If you remember back when we did the solving multi-step equations, there were 3 types of solutions, one solution, no solution, and infinitely many solutions. Well, that's going to be the same thing here. We're going to have intersecting lines are one solution problems. Now, for intersecting lines, what do we know? Well, we know that in order for 2 lines to intersect, then the slants have to be different. The way a line slants, that's their slope. In other words, if you have 2 lines and the slopes are not equal, then those lines will intersect. Again, if you have 2 lines that have the slopes that are not equal, then they will intersect. So make sure you have this right here written down. Pause your video to do so. Since these lines up here have the solution of 5, 7, that means that they are intersecting lines. They have different slopes. Parallel lines. Parallel lines have equal slopes but different y-intercepts. They have the same slope but different y-intercepts. And if you remember correctly, when you learned about parallel lines never ever intersect. So there is not a single point that would be true for one equation that would also be true for the other equation. So they don't share any common points. Therefore, parallel lines have a no solution. Underline the words no solution. So again, parallel lines have equal slopes, but their y-intercepts are different. So make sure you pause your video and get this right here written down. Now you may be asking, why is there an m with a 1 beside it and then an m with the 2 beside it? All right, that's just saying that the slope of line 1 equals the slope of line 2. Because remember, we have two different lines here. And then it's going to say that the y-intercept of line 1 does not equal the y-intercept of line 2. So once again, for parallel lines, slope of line 1 will equal slope of line 2. But the y-intercepts are not equal. Now coincident lines. Now this might be something you have never heard of before. Coincident lines have equal slopes and the same y-intercept. In other words, the lines lie on top of one another. So actually, if you were graphing it, you would only see one line because it's in other words, the same line. So if one line lies on top of the other line, then that means every point that is in one line will also be a shared point in the other line. And how many ordered pairs could be, or how many points could be on that line? An infinite amount. So for coincident lines, there are an infinite amount of solutions. Underline the word infinite. For coincident lines, there is an infinite amount of solutions. And once again, their slope, not only are the slopes equal, but the y-intercepts are also equal. If you would go back to when we were talking about one solution, no solution, and infinitely many solutions with one equation, it looks very similar. For one solution, the coefficients of the variables were different. Well, here, the slopes are different. But for no solutions, the variable terms were the same, but the constant terms were different. Well, for parallel lines, the slopes are the same, but the y-intercepts are different. And then for infinitely many solutions, both the variable and the y-intercepts were the same. Well, for coincident lines, which is an infinite amount of solutions, the slopes and y-intercepts are both equal. All right, so let's look at what these would look like on the graph. Okay, so here are intersecting lines. These two lines intersect at this point right here. So put a point there, circle it. All right, that point is the solution. All right, and because they intersect, that means it is a one solution problem. If we were to figure out the slopes of these lines, we would know that they are not equal. Do me a favor, and I want you to label this up here line 1, and this here line 2. Obviously, they slant differently, so that means the slope of line 1 does not equal the slope of line 2. So that point there is the solution. What is the ordered pair of that point? What is the ordered pair of that point? Well, we go this direction, that's -1, and then we go this direction, that's -2. So the solution to this problem is -1, -2. The way you write these answers, I know for multi-step equations, we just wrote one solution. But for these types of problems, when we're solving systems of equations graphically, not only are you going to mention that it's a one solution, but you're going to say what the solution is. So for this example, it is a one solution of -1, -2. I want you to pause your video, and you need to make sure you have everything that I have written down on your paper. So pause your video and get that all written down. So again, this is how you answer a one solution problem. If the lines intersect, that's how you would answer the problem. This is parallel lines. So let's label this line 1 up here and line 2 down here. These lines never ever intersect, which means they never ever share a point. And if they don't share a point, that means they don't have any common points. And therefore, it's no solution. For parallel lines, your slopes are equal, but your y-intercepts are different, right? If we took the time to find the slope is negative 1, negative 1, 2. So the slope for this, for both equations, would be negative 1/2. But the y-intercept here is positive 1, and the y-intercept down here is negative 2. This slope is negative 1, 2. So they share the same slope, but different y-intercepts. Parallel lines have no solution. They all have the same slope, but different y-intercepts. And these are coincident lines. It might be hard to see, but notice how there is a red dotted line, well, actually a red solid line with a blue dotted line over top of it. So the red is a solid line with a blue dotted line over top of it. So you could tell that this is both line 1 and line 2. They lie on top of one another. So they share every single point. And because they share every single point, they have infinitely many solutions. And because it's pretty much the same line, their slopes are the same and their y-intercepts are the same. So pause your video and get all of that written down. All right, so for this lesson, there's going to be 3 types of lines. They're either going to be intersecting, which is a one solution of, and then you would list the ordered pair where they intersect. If they are parallel lines, it will be no solution. And if it's coincident lines, then it will be infinitely many solutions. All right, if you have any questions about the 3 types of lines that we're going to be dealing with, please let me know.